Hello there. Hello. Hello. And the chat's not working. Okay. That's not great. Let me just fix that. I'll be 1 second. Just need to fix that. Let me just. Sorry. Sorry about that. Okay, now I have visibility of the chat. Okay, so here to read this book, Science in Sanskrit. I got this from family friends, and I think it would be interesting to read on the channel. So yeah, that's why I'm reading it. I'm just gonna check something really quickly, and then I'll get to it. I'll be 1 second. Okay, let's. This is terrible camera angle. This is horrible camera angle. Okay, let's begin. Astronomy. Too far now. Okay, now. Still too far. Like closer? Yeah. Okay. Astronomy. Let me check. Sorry. Okay. Astronomy. Solar energy. The world is due to the sun god. The living beings get their strength and energy from him. The fact that the sun the fact that the sun source of energy was the fact that the sun is the source of energy was well known to Indians from the Vedic period. Astronomy. Uh, Sun, the center of the solar system. The sun holds the earth and celestial region. Among of all heavenly bodies, the sun is the attracting power. An instance of Indian culture being knowledge-based always. Path of all celestial bodies in elliptical. Elliptical path through which all celestial bodies move is imperishable and unslackened. This is what Trinabhi Chakram. This is called Trinabim Chakram because to form an ellipse, 3 points are required. Ellipse is the path of a point that moves, such that the sum of its distance from two fixed points, called foci, is constant. In the Western astronomical tradition, up to the age of Coperna- Copernicus, 1473 to 1543, it was believed that the planets and other celestial bodies had circular orbits. Later, Johannes Kepler proposed a new theory in 1609. According to him, the path of all the planets and other celestial bodies is elliptical. I'll show you a picture kind of this. Yep. See the chat. Anjali Yadav. Oh, you're doing good. Good luck. Thank you. Thank you for that. It's very kind. Thank you. Um, let's continue. Okay. And welcome to the live reading, if you're still here. Next. Planetary motion. The mean planets move on their orbits, and the true planets in what is this actually saying? Mean planets. The sorry. The mean planets move on their orbits, and the true planets in eccentric circles. All the planets, whether moving on their orbits or in eccentric circles, move with their own motion, anti-clockwise, from their apogees and clockwise from their perigees. I don't know what that means. Okay, so I'm guessing it says over here this was written by some, or discovered, I guess, by some in ancient Indian guy called Aryabhatiya Kal Kalakriyapada in 499 CE. So that's after Christ. Okay, so Aryabhata stated this law in the 5th century AD, much before the first law of planetary motion was given by Johannes Kepler in 17th century CE. Wait, but it says here there was 499 CE. Now it says 80. Okay, anyways. And then it says underneath, break free from the orbit of the West. Cause of eclipse. This was, I guess, discovered by a person called, with the same first name, Aryabhatiya Golapada. And then it's shows sun, moon, earth, and I guess, yeah, and this is cause of eclipse. They discovered 499 CE also. So that. The moon covers the sun, and the great shadow of the earth covers the moon. Wait, I'm just gonna check. Okay. That Aryabhata, this demystified eclipse eons ago, stands eclipsed by misplaced credit. Well, seems true if that was hundreds, basically, like few hundred years the before Johannes Kepler figured it out. So seasons when comets influence the Earth. This is by Bigrat. There is some kind of writing over here, and then this was by Brihad Vimanashastram Kriyasatra Saratantra, and this is also on page 185. The influence of comets is high during autumn and spring, as they are naturally under the spell of solar rays. What a thorough, profound knowledge of celestial bodies. Number of comets. And then there's something written. This is written by Brihad Vimanashastra Kriya Sara Tantra. And this is also on page 185. In the 8th ring of the sky, there are what is it? 1,700,000 703,221 comets. So no, 3 million. Okay, in the 8th ring in the sky. So it's like between Pluto and stuff. So, and then by by a person called Brihad Vimana Shastra Kriyasara Tantra. I can't read that. Among the above comets, 8,000 are very fierce. 12 out of these 8,000 are again highly powerful. And next, the moon, the satellite of the earth. And this is by Rigveda and Tatiria Samhita. The moon, being the satellite of the earth, revolves around its mother planet and follows it in its revolution around the self-luminous planet, father planet, the sun. Yeah. So revolves around the earth, which revolves around the sun, which revolves around the solar system, which revolves around the universe. So I guess everything is revolving about around something. There are a total of 32 satellites in the solar system. The moon is the only satellite of the Earth with a distinct nature, while all other satellites have sizes below 1/8 the size of their mother planet, the Earth. This is the only satellite in the solar system that is very big. This was apparently discovered eight approximately 8,000 years ago. This is one great example of Indian astronomical genius in the Vedic era, approximately 8,000 years ago. That's crazy. Let me check the. Sorry, something is wrong with my computer. Okay, let's get back to it. Okay. Circumference of the Earth. The radius of the Earth is 800 yojanas. I'm not sure what yojanas is. I don't, if anybody here knows what that means, yojanas or something. I don't know what that means. So if anybody can clarify, yojanas or yojanas. Multiply this by 2, take the square of that and multiply it by 10. The square root of the figure obtained is the circumference of the Earth. Now that's got to be a lot. It is roughly 5,600 yojanas. I'm gonna uh, think that that means kilometers, or yeah. So that is so the radius of the Earth is okay. So I'm going, and then one yojana equals 8,000 dandas. What's a danda? The circumference of the Earth is 4,000. No, 4.008 times 10 to the 7th meters. So one lambda is equal to 1 point. Oh my God. So that means this is like, yeah, this is basically kilometers. Yeah, even more than kilometers actually. So that's crazy. And how they knew this long ago is insane. Orbiting planets. The concept of gravitation. And this is by, okay, so Sid, this is by Sid. Some in this was 528 CE. So by Sidhan, why do they have such long names? Sidhantarshiromani Bhuvanakosha 6. I'm guessing I don't know what 6 means. Massive, okay, so massive celestial bodies are attracted powerfully towards the Earth due to the gravitational pull, and they appear to fall as a result of such attraction. But when equal forces act on a body in space from all sides, how can it fall? The universal law of gravitation was propounded by Sir Isaac Newton, 1642 to 1727 CE, much later. And this was, oh, this was, so this is around 1,000 years before Sir Isaac Newton said this. So they probably have, I'm going to assume that they have some kind of script that they had over there in ancient Vedic time of India, and they probably had some kind of thing saying this, and that is 1,000 years before Sir Isaac Newton discovered this, which is very crazy. Think about that. 1,000 years, more, yeah, more than 1,000 years. Now, Nadivalaya Yantram. I don't know what this means. And this is by Siddhanta Siromani Yantadhyaya. And this is 528 CE also. This is a simple astronomical instrument. So I'm going to show this. This is a simple astronomical instrument of Hindu origin, commonly used by ancient astronomers. Bhaskaracharya describes this Nadivalayam as a circle of wood, the circumference of which is graduated into ghatis and its subdivisions. This dial is placed in the in the plane of the equator, and the vertical gnomon is fixed at its center. Okay, so the shadow of the gnomon, which is the thing they put in the center, is taken into account to determine the local time and hemispherical positions of the planets. This is known as Dhrupagati. Right. Indians, fomenting the astronomical calculations, devised various astronomical instruments. Okay, let me take 1 second. I'll be right back. Okay. I'll be 1 second, sorry. Okay, let's get back to it. Sorry, I'm taking too much time. Um, let's get to it. So that was interesting. Let's go to the next one. Shankhu Yatram, astronomical instruments of ancient India. And this is written by a surnamed Sadhanta Shiromani Yantradhyaya 9, 528 CE. This instrument okay, so I'm going to show the instrument, the thing they used, not the instrument, but I guess scientific instrument. That's it. This instrument made of ivory consists of a circular platform on the horizontal plane with Shanku post at the center, which is the thing in the middle. This is used to trace the sun's path and also to know several facts of astronomy. Thousands of years ago, Indian ancestors had made significant achievement in the field of astronomy. Speed of light. By Rik Samhita. The sun quickly pervades the whole world. Sanacharya, a celebrated saint, comments on the above text. Okay, this text above is in Sanskrit, so I really don't know what it says. Sorry. Uh, it is said that sunlight, or Hindu, I don't know. Yeah, Hindu, sorry. It is said that sunlight travels 2,202 yojanas in half a second. Nimisha. So 1 yojana is 9 miles. 110 yards is one is 9.6025 miles. 2,202 yojanas equals 21,144.705 miles. Time taken equals to 1/2 nimisha, which equals to 1/8.75, which equals to 0.114286 seconds. Thus, speed of light equals what? One. I can't say. One. One. Is this 1,000 or 100,000? I'm gonna say 185,000. 185,016.169 miles per second. So I might be saying that number wrong because it has a thing over here. So if you would like to see it, here it is. So you can see all of this. Yeah. Um, Let me check the chat if anybody said anything. If anybody's here watching, be welcome to say hello in the chat. I will answer when I can. Like right now, if you sent. Okay, let's get back to it. Um, and then modern value is 1,000 one. Okay, no. So yeah, 186,000 miles per second. So that means that's scary accurate. How much? That is 10 times accurate to what we have nowadays, to what they have then. I mean, it's not 100% that we know for sure that's true, but it most likely is. I'm gonna assume that it's most likely is. So that's scary how accurate that is. So yeah. Wait a minute, I'm just going to check something really quick. Okay, no. Let's get back to it. Anyways. Origin of matter. From that absolute cause, either came from either the air, from air the fire, from fire the water, and from water the earth. The secret of creation of matter is, and then it says a bunch of, I think, I think Sanskrit words. Akasha, Vayu, Akasha, which is, I think, air, Vayu, which is wind, um, Agni, which is fire, Ap, which is water, and Prithvi, which I think is earth. That's what I'm going to assume. Yes. Now, it says underneath this, modern physics gives the sequence as plasma, gas, energy, liquid, and solid. It also states the interconvertibility of matter and energy. So yeah, it's exactly the same. And this was discovered what probably even before the this, which is crazy because that's insane. I'm gonna assume it was before this because lots of these seem to be like 500, 600 years before, like other from West discovered it. Cause and effect, and then some Hindu thing, text, or Sanskrit. I don't know. This book is called Science in Sanskrit, so I'm thinking this is written in Sanskrit, but I'm not sure. Now, here it shows cause, effect, effect. There is no effect possible without a cause, but the absence of effects does not mean the absence of cause. The text also substantiates the above fact with an example. Applying a force less than that needed to overcome a friction will not make a body move. In this case, the cause, which is the force, is present, but not the effect, the motion. So, yeah, it's showing that cause does not always equal effect. Something happens, it doesn't equal another thing going to happen after that, like a row of dominoes. It can stop before it. I guess that's what it's trying to say. But let's see. Varieties of magnet. Magnets are of five basic varieties. Brahmaka, Chumbaka, Karshaka, Dravaka, Romakanta, and Romakanta. These have six sub-varieties: single-faced, two-faced, three-faced, four-faced, five-faced, multi-faced. The above 30 varieties of magnets are in three colors: yellow, red, black. Magnets are thus characterized into 90 varieties. How does that make sense? What? I didn't get that. If you understood that, let me know. Okay, let's go to next. Physics is a quantitative. Okay, so units and measurements. Okay, this is a longer one, so I'm going to This is a longer one. I'm going to check something very quickly. Um, yep. Okay, nothing in the chat. Okay, let's get to this one. This is a longer page. Units and measurements. Physics is a quantitative science. Its methods often involve measurements. This requires defining standards and then expressing interrelations between the various quantities. Historically, there existed many different systems of units in different countries over the world. The most popular among those used in scientific works were: first, FPS system used in Britain; second, the CGS and its practice; three, the MKS system used in France. Indian scientists too had to involve a unit system. Given below is the scheme for the length measurement used in ancient India for the construction of building, religious altars, etc. Building, construction of building, religious altars, and more. The fundamental unit of length is called, in Sanskrit, I think, paramanu, which is defined as the sixth part of the smallest particle in seen in beam seen in a beam of sunlight entering a room through a window. In modern science, seeing micro-sized dust particle present in a room illuminated by sunlight. In modern science, seeing micro-size dust particle present in a room illuminated by sunlight by the process of scattering is known as Tyndall effect. The length scale based on para I can't read because of the picture. Paramanu, the length scale of based on Paramanu. So I'll show you a little picture. So before I start reading all this, I hope you can see that. But yeah, okay. So I'll just say it. 8 Paramanu equals 1 Traseranu. I don't know what any of these mean, but there's some kind of measurements, units and measurements, units. So 8 Meramenu equals 1 Traseranu. 8 Traseranu equals 1 Renu. 8 Renu equals 1 Valagra. 8 Valagra equals 1 Lykia. 1 Lykia equals 1 Yuka. 1 Yuka equals 1 Yava. 8 Yava equals 1 Angula. 24 Anguli equals 1 Yastha. 8 Yastha equals 1 Danda, and 2000 Danda equal 1 Krosa. 4 Krosa equal 1 Yoyana. Ah, well, this goes deep all the way to the smallest measurement. My God. Who needs that though? Mike, that's insane though. The radius of the Earth equals 800 Yoyanas, which is approximately 800 kilometers from what I saw before, but I'm not 100% sure yet. So I'm just gonna say Yoyanas. I'm gonna estimate that it is kilometers. The circumference of the Earth is calculated by multiplying the radius by 10 and then by d or 2r. 1 danda equals 1 meter approximately. Further, 1 paramu equals 50 angstrom approximately, which is of the order of molecular dimensions. It is astonishing that figures given for the circumference of the Earth in the Rig Veda and Surya Siddhanta are the same. I don't know what either of those are. Sorry if anybody knows, let me know. Think we'll do 2 more pages, and then after I'll stop and I maybe will read a little bit of some other book. And then we'll continue on some other day with this book, of course. Sorry. Yes. Um, Here it shows a little electricity. So now this is crazy because electricity wasn't invented until in well, at least in the West. I'm supposing it was first invented in the West, but I don't know anymore. But anyways, supposedly invented like around invented, but electricity like in 18 19th century, I think 18th century electricity. So yeah, that is yeah a long time ago, 200 years ago approximately. And so it says on the top part zinc with mercury, in the middle powdered wet wood, and on the bottom copper sulfate, and on the middle of that a copper plate, and then all around is a clay pot. These shlokas speak about electricity generated from batteries made hundreds of pots containing copper plates and chemicals buried in the ground. So they were making some kind of batteries back then. Probably, I'm guessing it seems like it would be solar made. But yeah, I'm going to all confirm with all these things later, but I'm taking this as fact now. The multicolored rays of the sun, dispersed in a cloudy sky, are seen in the form of a bow. It is called the rainbow, several colors in white light. I'll read another 2 pages. So, motion. 1. Motion is the cause of conjunction, this conjunction, and velocity. 1. 2. The upward throw is a result of force applied against gravitation. 3. Motion of precious stones and compass needle is due to invisible energy. Yeah, I never really understood like compasses and magnets. I really don't understand it. I need to check about that, but I really don't understand it. Next, lens. That which cannot be perceived with naked eye can be perceived with the help of instruments, with lenses made of kacha, which is glass, ab ab abharapatala, which is mica. I don't know what that is, and spatica, which is crystal. And then it shows a picture here of this, which is, I'm guessing, the way you see through a lens, one of the like glasses or telescope or all those things. I forgot what it's called, the thing you put, but yeah. In another invention of Roger Bacon, Roger Bacon, CE 1214 to 1292, is the lens. A lens is a piece of glass or any other transparent material with one or both curved surfaces. It can converge or disperse light rays passing through it. And this was what? 800 BC. That is before Christ. I'm definitely checking this if this is true. I need to study this because this is super interesting. Anyways, I think I'm going to stop here and I will come back maybe again now soon to read the book of the Magic Faraway Tree, which I've stopped for some reason, and I'll just come back to read a little bit of that, something light, something that's just fun and funny and stuff like that. Let me check the chat if anything happened. Check if anybody said anything. So if anyone did, I can just say hello. No, nobody did. Okay, well, hope you enjoyed the reading if you're still listening, or if you're listening on the catch up, which is people who come after. Yes, you will know if you're listening on the catch up. And yeah, thank you for coming here if you did on the live. I got surprisingly a lot of people here today. It was going on and off. One view, two views, zero views. One, two views, zero views. One view, zero views. So yeah. So yeah. See you next time, and hope you enjoyed. And we're basically a quarter of the way through this book, which is insane. Less than a quarter, but yeah, it's pretty short though. So tomorrow or maybe the day after we'll read again, and I think we'll be done in 3 or 2 parts. Depends how much I read on the next part. So yeah, see you later, alligator. Um, bye bye.